This is Josh White with JW Math Tutoring. In today's video, I'm going to highlight some problems from the October 2025 Digital SAT Math Test that I've covered previously and are repeat questions. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Before I begin going through the problems that are listed on this worksheet, which is technically the third one in my October 2025 Digital SAT Math official problem set series, I just want to mention a couple things. First, obviously, if you like this video, please give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, there'll be a link to this PDF file in both the description of the video and also in the pinned comment on the video below. Third, if you haven't done so already, please check out video worksheet number 1 and video/worksheet number 2, which each have 10 essentially new or unique problems. And now, just to explain briefly what I'm going to do in this video. So I mentioned this in the other two videos, but in case you haven't watched those, okay, this video is specifically going to highlight what I call repeat problems. Okay, so these are problems that I've either covered multiple times already, or maybe I just covered very recently, like in either September or possibly August. So I'm not going to go through and work out each of these problems. Instead, what I'm going to do is just highlight the problem or one example of the problem, and then you can see listed below it are the specific months and years and worksheet number and problem number, to go find. And you can go find the problem there worked out in its entirety. Now, obviously, the numbers will be a little bit different than maybe this example that's on the screen here. But the point is, that is exactly, if you got a problem similar to this on your October exam, then you go to that worksheet from that year, that month, that problem number, and you can find, a virtually identical problem to work on. All right, so with all that being said, let's go ahead and go through these again. So this is going to be pretty quick, pretty short video. So the first one is the type of problem where it's like, you have x minus k, which is some constant, like squared on one side, and then on the other side, it's k minus 5a and x minus k. Again, it's essentially a quadratic. A and k are both constants. This inequality here technically doesn't really matter in terms of how we solve it. And then you're told the sum of solutions equal to blank. And this sum of solutions is always like something k plus something. It's typically 3k plus, and then the number changes, right? And you have to solve for a. All right, that's what you're solving for. Anyways, this was previously featured October 2024, December 2024, also again in August 2025. So go check out the solutions to any in any of those videos, problems on those specific worksheets to see how to do this one. All right, next one, the one about the volume of the wall of a pipe. So this one first came up in August. It's a basic setup where you have like a pipe here, and it has a certain thickness to it, and it has a given height or whatever, and they want to know basically how thick is the actual pipe itself, because it's open in the middle, water flowing through it. Okay, so go ahead, check out August 2025. It's worksheet 1. It's problem number 1. That'll show you exactly how to work it out. Again, the numbers will probably different than what's listed here, but you get the idea. All right, next up, so basic percentage questions. This one, this is a percentage question where it's like A is so many percent of C, and B is so many percent of C, or A is so many, or A is so many percent of B, or however they choose to set it up. It can vary, and then depending on how it's set up, they might say A is P percent of B, or in this case it was A minus B is equal to some constant W times C. In other words, it said the difference of A minus B is what percent of C, essentially. In any case, if you had something similar to this, go check out October 2024, worksheet number 1, problem number 6, to see how to solve this. Another one that was just done fairly recently, in August 2025, was a problem where you're given some function. It's basically an exponential function, and it asks about what the new function would be if you took the original and you multiplied every y value in it by some number, like by 50 or by 20 or by whatever. And typically, you're given, I believe, a graph of the original function. But the answer choices are not graphs. The answer choices are equations for the new function. So again, if you want to see an example of this, go to August 2025, worksheet 3, problem 3. Okay, for this next problem, just a little quick note. This small portion of the video is recorded after I recorded the main part because I actually found another problem that is identical to this one that's listed here that I'm going over now afterwards. The August 2024 worksheet 3 problem I did not have at the original time of recording, but I did find it afterwards. So that's why in the rest of the video, you would only see one problem listed under this specific one, but right now you're seeing two, and in the PDF file you download, there will be these two listed. Anyways, this problem is one where you're given either the area or the individual side lengths of some type of figure, usually like a rectangle, some rectangular space or area, and it tells you that like on this scale or on this model, each side length is 1/10 or 1/20th or something of the actual length. And then it asks you basically what's the size of the scale model or something related to that, something where you basically use the scale factor for each side, but you have to square it because it's an area factor and so on. So anyways, there's one example on August 2024, worksheet number 3, problem 9, and then a second example from linear paper test 10, module 1, problem 22. Those both cover basically the same type of problem as what's being discussed here. Okay, and anyways, now back to the rest of the previously recorded video. Okay, next, there's a question about generalizing survey results to like groups of people or students or whatever. In other words, you randomly select students who participate in a survey, and it wants to know like what's the largest group of people you can generalize the survey results to. Go to August 2024, worksheet number 2, problem number 3 to see a very similar problem to this. Moving to the next page. The predator and prey question came back again. So this one is the question where it's like the predator and prey are both the same at the start of a week, and then the prey increases by something percent, the predator increases by a different percent, and then it says, find the percent greater than 1 or less than 1 that the other one is at the end of the week. Okay, that's the basic setup. So we have 4 different options to look at this one. You can go all the way back to June 2024, worksheet 1, problem 20. There actually only was one worksheet way back then in June. I just put all problems in one thing. But then also more recently in December, I did it again in March 2025, and then again in June 2025. So you have multiple examples to look at. All right, the next one. This is the problem type where you have 2 cylinders, and notice it could also be different 3D figures. It doesn't have to be cylinders. Sometimes it's rectangular prisms, i.e. boxes, but you have 2 similar 3D figures, right? And they give you a relationship between like the volume of one to the other, and they also give you other basic information such as like maybe in this case the radius and the height of one, and you essentially have to find the difference between the surface areas. So in this, this example, like it was n minus k, where n and k were representing the n pi and k pi representing the surface areas of the 2 cylinders, and you just want to subtract them. You could also see variations where they give you a surface area and they want to find the difference in the volumes, but it's the same basic idea, same basic like principle where you're finding the volumes and everything. And this involves using like, scale factor, area factor, volume factor. In any case, December 2024, worksheet 3, problem 7, or August 2025, worksheet 2, problem 9. Very, very similar problems to this one. Next one, the swimming pool with the concrete path or concrete walkway, like around the outside of it, and the width of the walkway is X, and they give you information about it, like, you know, the size. I think they give you the size of the pool, and then they also tell you like the total area of everything, like the pool and the walkway together. Anyways, if you got that problem and want to see how to solve it, go to March 2025, worksheet number 3, problem number 2. That problem worked out in detail. Next up, so this problem is actually a copy from a Blue Book practice test problem. It's from Blue Book practice test 9. It's from the second module, the harder one, and it's problem 17. Basically, you have this quadratic, and then the way it's set up is there's 3 answer choices. It says, what are the solutions to this equation? And it's like 1, 2, 3, and then they give you these, and then the answer choices are like, 1 only, 1 and 2, 1 and 3 only, 1, 2, 3, like combinations of, these different values for them. So, if you want to see how to solve that, again, go, if you haven't done it already, check out Blue Book Practice Test 9, Module 2B Hard, number 17. Although, if you haven't done Practice Test 9, I personally would wait until you have completed that practice test to look up the solution to the problem. All right, next, unit conversions, and specifically, unit conversions dealing with areas or or specifically things being squared. So in this example, the student remembered, it was square meters per hour to square meters per minute. Wait, that doesn't actually, um, yeah, that should actually be wrong. This should actually probably be like square centimeters, not square meters, because then you're only converting hours to minutes, and that's not, that's not a lot of work. So that should actually probably be square centimeters, because, yeah, right here, 19 per how many meters squared. Or if you look at the second thing, these I think are technically 2 different, like, posts, 2 different comments that I copied from. Yeah, here, 1980 centimeters squared per hour is how many meters squared per minute. I'll fix this, by the way, on the PDF file to change this to square centimeters. But in any case, if you want to see how to do unit conversions when you have to square one of the conversion factors, August 2024, worksheet number 3, problem 4. All right, next, finding the surface area of a rectangular pyramid. So in other words, it's a pyramid, but the base is a rectangle, not a square. If you want to see how, if you had this problem, you want to see how to work a very similar problem out, go to August 2025, worksheet number 2, problem 4, to calculate the surface area of that pyramid. The last one is the one dealing with penguins. I mean, technically, it's like a weighted mean that you're finding out. You're given like 2 groups of penguins, and there's like so many in one group, and the mean is this, and so many in another group, and the mean is that. You can also technically set it up as a frequency table, but in any case, if you want to see how to solve that problem, May 2025, worksheet number 2, problem 6. Okay, so as I said, this is just kind of a quick, much shorter video to highlight the repeat questions that, I've already solved previously in other videos and on other worksheets. If you did like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, check out worksheet/videos part 1 and also part 2, which have 10, essentially new problems on each from this October 2025 digital SAT math test. And lastly, if you want to improve your knowledge of Desmos, please check out my Ultimate Desmos Guide to Digital SAT Math. It is now up to over 6 hours of tips and tricks and instruction and 65 practice problems to help you ace the digital SAT math section.